All right, good afternoon. I think we'll get started. So, in January this year, Reed Hastings, founder and CEO of Netflix, got on stage at CES and announced to the world that Netflix was going to expand to 130 different countries that morning. That put the Netflix service at a total of 190 countries worldwide, and it was localized in over 20 languages, and kind of solidified our push to be a global streaming company. This here is our user interface. Quick show of hands, how many people here are Netflix subscribers? Yes. So you might be familiar with this. This is showing my favorite Netflix original show, Daredevil, and localized in Spanish. Daredevil fans? All right. Jessica Jones fans? Yeah. All right. But we didn't start off being a streaming company. We started off here. How many people were DVD or are DVD subscribers? Okay. So the company started in the 90s delivering DVDs in these very iconic red envelopes. And I think I've even heard Reed say that he's always intended for Netflix to be a streaming company, just the initial version of our company had a very high latency for the delivery of the first bit. So this is where we started, and we started off being a streaming company, delivering our service via data center. And at some point, we decided we were going to become a streaming company. And in 2007, we started our migration, our push to the cloud, to become streaming. And our service started off in the data center. So we built all our web services as a Java monolithic application inside the data center, built on top of, I think, Oracle at the time. And the company came to a conclusion that we weren't good at building data centers. And that realization led us to look for alternatives to being a company that also builds data centers, to being a company that builds a streaming service and offloads that basically the building of a data center. And that's when we decided to migrate to the cloud as a company. And it was a big risk at the time. No one had done it at the scale that Netflix had done it. And we chose Amazon Web Services. And I think we constantly get asked, are we going to switch to any other services? But at the time, and still to this day, Amazon is the most mature web service. And we gain a lot of benefits from binding ourselves to a single, and building our application on top of a single provider. So as we migrated to the cloud, we as a company discovered a lot of the pains of migrating our web service from a monolithic Java application running in a data center to a fleet of microservices running in the cloud on Amazon. We learned all the problems with running something at scale in the cloud. And these learnings ended up being codified into code and patterns. And these patterns and code got turned into the Netflix OSS offering. And so Netflix OSS has grown over time. It's now at about 128 different open source projects. Here's a picture of some of the icons from Netflix OSS. Anyone use any Netflix OSS projects besides Nebula? I assume just everyone uses Nebula here, right? No? Okay. So Netflix OSS covers a whole fleet of different offerings, from big data in the cloud to security in the cloud, but it basically codifies how we have developed our cloud service, and we decided very early on to open source this. And so I actually tried once to try to talk about every single open source project, and it was a very boring, long talk. So today I'm just going to focus on those open source products that we use to build and deploy Netflix to the cloud. And I'm going to really focus on how you can take some of these tools and potentially build your own service that deploys to the cloud. And this talk is, I think, to a lot of Netflixers, this seems like a very simple talk in that we're talking about some of the basic stuff. Earlier this year, I don't know if anyone's read this tech blog post. My team wanted to talk about some of the things we're doing and where we're going. We decided we hadn't told the story about how we build code. We released this tech blog post on the Netflix tech blog on how we build code at Netflix, thinking very little of it. And it ended up being the 4th most read tech blog ever in the history of the Netflix tech blog, which is a pretty big deal. And so I think that inspired us to say, well, we should probably talk more about some of the basics of how we deploy software at Netflix. And so for today's talk, I'm going to go through kind of 4 steps, walk us through 4 steps of how to deploy the service to the cloud. The first is we're going to talk about how to create a Java web microservice, which should be the very simple. We're going to install and bake this microservice, and I'll explain what baking is. We're going to define an AWS deployment, and then we're going to create a deployment pipeline. And being a visual person, I tend to think of these things in pictures. You can visualize what we're going to do today like this. So we have code that we're going to build. Our intermediate build step is an OS package. In this case, I'm showing a deb. And then we're going to take that deb and bake it into an Amazon machine image or an AMI. And this is going to be our unit of deployment. And I'll touch more on what baking is and what an AMI is. And then we deploy that application server group, or the auto-scaling group, which is an AWS construct, and route traffic through an elastic load balancer. All right, so let's start with this microservice. So the microservice we're going to build is just a simple Groovy application based on Spring Boot. I chose these things because I come from a background of Java, being a Java developer, and I suspect most people here have some foundation in Java. We're not going to spend too much time on it. I also chose it because the whole application, all its code, everything like that, sits right here on the screen, right? So you have your import statement for Spring Boot up here for all the Spring Boot framework. Your annotations, the meat of it is right here, which is I'm going to basically create an endpoint at root, hello world, and what it's going to return is a JSON object that has a key of message and a value of hello world. This is the main method, which will boot up Spring Boot, and it will allow me to make my application a runnable jar or WAR file. And that's really it. So to get this code into a WAR, we're going to do something that no one here probably is familiar with, which is build our code using a tool called Gradle. Anyone heard of Gradle? OK, good. I'm in the right place. And so the Gradle build script looks something like this, where we have our plugins we're applying at the top, when I'm including Groovy, Spring Boot, WAR, and application. A lot of typical stuff you'll see in a Gradle build script. And at the bottom, the dependencies right here. I'm not going to spend too much time on this, because you all know Gradle pretty well. And when we run this build, it's going to be a very simple, clean Gradle build. Runs very quickly. And when we're done, we have an application. So we have the nice part about applying the Gradle application plugin, it gives us some distributions. So we have a tar and a zip, and we have some scripts that will start up the application. Now, before I came to Netflix, this would probably be where I stop, and I would stop with this application with these startup scripts and these zip, and I would turn to somebody on maybe the ops team and say, here you go, build this, turn this into an application. And I think as the DevOps community grows, we start saying the answer to this might be, I'm going to use Chef, I'm going to use Puppet, I'm going to use Ansible to connect to that machine, deploy and deploy these services, and start them up on the server. And we've learned to take a different approach and use something that's very familiar to most most sysadmins, which is using just the OS packaging systems. So something like a deb. So now that we have our code, we need to turn that application into an operating system package. And to do this, the reason we want to do this is we want to employ what's known as the immutable server pattern. And the immutable server pattern is kind of the core principle of how we deploy code at Netflix. So the background of this principle is that you never want to change code running on an instance. So if we're using Chef or Puppet, what you're basically doing is you're treating your servers like, you might even name your servers. I don't know how many people here have ever been named a server. And you're connecting to that server, and you're changing the code and restarting the code. With the immutable server pattern is anytime you want to change a line of code, you recreate a new virtual machine, and you recreate it with all the bits you want on there, and then you destroy the old virtual machine. And this is a core principle of how we end up scaling and building applications at Netflix. So every single time I want to change one line of code, I go through this whole process to create a whole new virtual machine, stand that up, route traffic to that new virtual machine, and then kill the old virtual machine. This makes it easy for us to eliminate problems such as configuration drift, which can be a big problem after a while on an instance. So we're also able to scale up and scale down our fleet very quickly, because we're not installing every single time we stand up a new server.
Is there some work in building a base AMI that all these things will point to?
Have you been cheating and looking at my slides? Yeah, we'll get there. So I'll cover that. Right. So to do this, we'll start off with Nebula. And you've heard a lot about Nebula at this conference and in past years and even today. And Nebula has a whole host of plugins. Rob gave a great presentation before me that talked a lot about these plugins. I won't cover these. You can go to the website and check them out. We're going to cover one plugin in particular, the OS package plugin. And oh, by the way, I'm pretty proud that I just put together these T-shirts. There's some T-shirts here. So if you're interested in a Nebula T-shirt, ask good questions. This gentleman here already can get a T-shirt because he's got a good question in. But come find me afterwards. So to build our application, we have to update our Gradle build script to include OS package. So the blue on here is I'm applying the plugin as well as adding it to the class path. And the magic here happens in the red. And I know I'll blow that up. And this is how OS package generally works. Is you're going to have a block in your Gradle build script that's going to define what you want your application to look like or what it needs when you install it on the host system. So here we're defining two require statements that says we want JDK and Tomcat 7 to be installed on this machine, that we're basically saying our application needs this to successfully install. And then this from block here says we're going to take the output of the from the war task, the Gradle task, and we're going to put it into the /var/lib tomcat7 web apps directory, and we're going to rename it to root.war. And root.war just happens to be the special war inside of Tomcat. That is the default, and I think it defaults to the root class URL on that instance. And the last one is I have a pre-install script that just basically says run this command to blow away whatever was the root application before. And that's it. So now, since all our applications are single-tenant on a service, I can just assume I'm going to be the only application running on this operating system, the only one running on Tomcat, so I can take up the root. And this will basically install our application. And so building this from using Gradle is simple. We have one more command we run, which is build, in our case, deb. And it creates our Debian, which is sitting right here. So now we have a deb file sitting in our distributions directory. And we also have some output from that Debian, which are the controls, basically the constructs that get included into the Debian. So what this allows engineers at Netflix to do is to create an operating system package that from their application without having to know the details of how to create a deb. And it does it right from Gradle, something that they're already using. So that gets us our installable application. Question?
Does that plugin have any dependencies across the network? Does that pull down anything across that?
You mean at the time it executes a build deb command?
Yeah.
Don't think so, other than dependency resolution for the plugins.
It is the OS package has dependencies, but
Right.
it doesn't fetch anything else unless you tell it to.
What's the library it's using? JDeb?
JDEP, yeah.
Yeah. OK. So by the way, the whole process of creating a deb, I think if you don't take anything else away, like you can use this without going to the cloud. If I would have known this like 10 years ago, I would have been using this all the time with every single application I ever used. Is there a question in the back?
Kind of. It's more of an idea. You conceivably set your mechanism to actually also do the test drive and just install that. And potentially, if you have multiple modules, depending on new devs that you just created,
Right.
doing the whole chain from Gradle.
Yeah. So in theory, yes, you would, but I would probably recommend doing something like Vagrant at that point.
Then technically, you just re-implemented the Jenkins portage system in Java.
Yes. OK. Can't tell if those thumbs up good or thumbs up like.
Better grade.
Yeah. OK. So we have our installable Java service now, and we're ready to go. So the next step is to install it and bake this microservice. And so like I said before, our unit of deployment is not a web application or a WAR file. It's not going to be this deb. Those are both intermediate steps getting us to our end unit deployment, which is an AMI. And we have this process we call baking at Netflix. And baking consists of combining two components together to create an AMI. The first component is a base Amazon machine image, and the second one is the deb we just created. And those, we install that base, we install the deb onto that base Amazon machine image to create our application-specific AMI. So the pipeline kind of looks something like this when you look at like how the base AMI fits into our pipeline with our application. We have the vendor operating system that comes from someone like Canonical, right? And they will provide a version of our application. We will then turn that into our foundation AMI. Amazon provides some of these. We might do something to tweak that foundation AMI. But in general, then, our internal team has a set of packages or debs that we add onto our base AMI for, to basically create that base AMI. In this case, I'm showing default JDK and Tomcat 7. At Netflix, we actually have a whole bunch of hosts of utilities, functions, stuff for monitoring that we add onto the base AMI that we think every single application Netflix could benefit and utilize. And then the deb can just be installed, and it creates that application-specific AMI.
Is it already on there, or do you add these things as part of this pipeline?
You mean like the default JDK and Tomcat 7?
No. Those you're adding, right?
I'm adding those to a base AMI so that when...
Base AMI already had all your stuff on it.
Yes, but...
Pipeline for building that. Is it just manual?
No, this would be... At Netflix, we would have this be like a Spinnaker pipeline, which I'll show a little bit later. So that is also a very automated process with tests. And so when we have a candidate release process, we have unstable process. So we will release the base AMI cadences with security fixes, everything like that. I'm not going to talk about that, but we can discuss that if you're interested. Yeah.
Why did you guys choose to install it into Tomcat versus Embeddable, Circuit, and Spring Boot?
So in this example, so Spring Boot is actually not the framework that we use generally at Netflix. So that's answer number one. Tomcat, because our teams like the performance team have a lot of experience tuning and performing, adding performance, or tuning and monitoring those Tomcat, so I think it just makes sense. You can think about this as kind of a platform or a Netflix-specific PaaS, right? So we're basically providing, if you add your WAR into this PaaS, you're gonna get all this goodness from all these centralized teams, not just from engineering tools, but from performance, from the insight team as well. And so if you put it in this location, you get all these other things for free. You can, in theory, and there are teams here, I don't know where John is. John has decided he wants to do, for some of the services we build on Eng Tools, he wants to create just a Spring Boot runnable WAR file, jar file, and he does that. And which means he has to do some additional things to make it work well within the ecosystem, because he's kind of deviating from our spec. Does that make sense?
Yeah. So it's just fits in.
Yeah. And this standard has been around probably definitely before Spring Boot, but not before Spring. So, yeah. Okay. So to achieve this, what does all the baking is a tool called Aminator. So Aminator is an open source tool that is in Netflix OSS, and its job is to take that base AMI and combine your deb and create your AMI inside AWS. And so the output looks something like this. I did not do a screen capture, mainly because it takes longer than I think you're willing to wait for it, and I can talk about how long it takes. But the key command we're running here is this. So it's a Python library, and we're running the aminate command. We're telling it a couple of things. We're telling it, first off, this is the deb we're using. And this deb was the one we produced. We're passing in also which base AMI we're going to use. And this is an alias name to the base AMI, which is just, in Amazon terms, just another AMI that exists. And then we're telling it some things about the environment, which is we're going to run an EC2, we're going to use aptitude to install, and this is Linux. Aminator out of the box comes with other options that are available to it. And you can see, if we go back, it's doing things like performing a local install of this deb, and then it's registering this AMI into the cloud in AWS. So when Aminator finishes baking, your AMI is sitting in AWS, and it's available for any service to start at that point. And so the reason we went down this route is also Amazon is taking all the heavy lifting of distributing those bits throughout the cloud and making them available, and it just becomes an API call for us. So when I talked about it taking some time, baking is not, you don't get everything for free. One of the costs of baking and taking is the time it takes to bake. So this shows a chart of kind of a very simple application going through the commit, build, bake, startup, and then shutdown process. And that in total takes about 10 minutes, which you can see the majority of the time here in red is where the bakery is doing an AWS snapshot. And then over here, when instance launched, they're spending a fair amount of time launching the instance in AWS. These are things that we can't control, right? These are outside of our control. We know that snapshot time takes longer in different regions. So we know that some regions we're going to get faster snapshots and slower in different regions. So this is just, baking isn't for free. Has anyone ever used Packer? OK. So Packer is very similar to Aminator. In fact, you can achieve very similar features as Aminator. One of the key tricks here is that when people use Packer, they say it's slow. It takes about 20 minutes. And the reason it takes us, about 5 minutes here, maybe a little longer, is because we have worker nodes sitting there with Aminator ready to go. When you run Packer by default, it's going to connect to the cloud. It's going to make an AWS call to stand up a node and then do the installation there. So now your time is all about standing up the instance, setting up the instance, then doing the baking, then shutting it down. So to increase the performance of your baking process, you would really want to stand up worker nodes. And they don't recommend it because obviously those worker nodes are sitting there idle waiting for people, and that's just dollars, right? So there was a question?
Oh, yeah. So if I understand correctly, let's say you have an auto-scaling service. You just take one EMI for this, and then you can have like 50 or 60 worker instances spawn up on that. Is that correct?
Yeah, so the process of deploying an application would be, I would go through this process, bake one AMI. So when this process is done, in theory, I can tell AWS, now that I have this AMI in the cloud, I want 500 instances of it to stand up right now. And that's an AMI, that's an API call to AWS. And now, since it's already all installed and everything's all set up, AWS is just going to manage all of that for me.
Really quickly, and I can see the benefit from that over. I know in AWS startups you can have a startup script and you can even give it the S3 location of your dev package and just have it start up right away. But it seems like this would be much faster.
Yeah.
Start.
Yeah, exactly. OK, thank you. So we've gone through creating our installable web app microservice. We've installed and baked it, and now we're ready to go. We need to tell now AWS about our deployable. And this is the last stage of that deployment pipeline right there. So we're going to create our ASG and define this ASG. Now, how many people have built something in the cloud before? OK. So if you haven't before, you might just ask, standing up an instance it's just, I just launched an instance, right? I take my AMI and launched it. And the reality is AWS needs a lot of information to make an instance reliable and ready to use for customers. A very small list would be you need your Amazon machine image, which we've walked through the process of creating that right now. You need to create security groups. Security groups define the ingress and egress permissions, who's allowed to talk to this server on what port, what is this server allowed to do. You need to define launch configurations, which tell AWS when you're creating an instance using this AMI, what are all the security groups and other information to create this instance and stand it up. You need to define elastic load balancers, which route traffic between all the instances. In the event, say you want to do something like a web application. And auto-scaling groups define a group of homogeneous instances that you can scale up and scale down that cluster based on certain rules. To handle all of this and to simplify this for our engineers at Netflix, we built Spinnaker. Has anyone ever used Spinnaker? Tried it? OK. Netflixers are not allowed to say that. Has anyone heard of Spinnaker? OK. Is anyone here to just hear about Spinnaker? So it's OK. It's OK. It's a safe space. So Spinnaker is our next generation global cloud delivery platform. And you can think of Spinnaker as kind of the second generation of how we end up deploying services to the cloud. we previously had a system called Asgard, which was a Grails-based application, which you can consider something that added basically standards on top of AWS, where AWS didn't define things like applications. And that served us very well. It was a monolithic Grails application. We started to see how that was falling apart as we grew as a company. It also didn't, it really was just sitting on top of AWS. It didn't have constructs like continuous delivery baked in. And so in thinking about how we were going to involve Asgard, we decided rather than involve Asgard, we were going to rewrite and rethink the whole cloud delivery platform. So it basically has all the function of Asgard kind of imagined. We have deployment pipelines built in. It's a microservice architecture, which is also very different, and it's built on Java and Spring Boot, Java and Grails, Spring Boot microservices. One other thing of interest for Spinnaker is we also noticed that a lot of people were taking Asgard, which is written to work with AWS, and rewriting it to work, or rewriting parts of it to work for Google's cloud or Microsoft Azure or IBM's cloud. And so we thought about that building Spinnaker. If you were to use Spinnaker today, it will work with AWS, with I think GCE, with what are the other ones? Pivotals, Azure. Yeah, so there's a number of cloud platforms you could use today with Spinnaker. And so to get started, the best place to get started, I think, is probably the community AMI. So if you were to go into AWS and you had your own cloud, if you wanted to try Spinnaker today, if you just search for Spinnaker in the Amazon machine image search, there's a number of AMIs already pre-baked that the community and the Netflix team are helping to create. And so when you stand up Spinnaker in your cloud, it's going to look something like this. So in this case, I deployed in my own small little cloud an instance of Edda, which Edda is another open source, Netflix open source tool. And in this instance, we're looking at a bunch of search filters over here. We're looking at a cluster in this account, my AWS account, of the application called Edda in the US West 2 region. And you can see here this little chiclet thing. It means there's only one instance. You can see that we've given ourselves a lot of room to add a lot of instances. And I don't have a picture here showing some of our larger Amazon deployments, but they have lots and lots of chiclets filled out with all the instances being deployed. And so to create our deployment, our Spinnaker makes it very easy. So we can create our application using a simple form. We'll add our application name, our email address. And then one thing right out of the gate that Spinnaker does differently than Asgard is it really considers where this code is coming from. It's going to ask you what the source repository is for your application. So in this case, I have a GitHub application. And then it's going to ask me which account to run, and we create the application. It's going to ask me to create some security groups. I'm going to create these security groups. The most important bit down here, which I'm sorry I didn't explode this up, is the ingress permissions. And so I'm telling this security group that I'm allowing traffic to go to my instance on port 7001, HTTP traffic on 7001. And then I will create a load balancer that says, expose your domain a DNS entry and route traffic between any instances in this ASG that get created. And that's kind of really it for creating an application. So Spinnaker makes this a lot easier to do this in a very opinionated right way. It's going to assume you're going to be baking AMIs, and you can create deployments that don't bake AMIs with Spinnaker, but it's going to build those assumptions right into the API.
So what you did, you kind of created a container source for you to deploy for all the other plugins and pipelines you mentioned to start using AMIs, refreshing the AMI, baking the AMI, replacing it.
Right. So yeah, exactly. So then, I think in my pipeline, what I will say now is I'm going to create a pipeline that says every time there's a commit or a build in a Jenkins instance, then we're going to bake it, and then we're going to deploy it. And so we can create these deployment steps.
So in your build pipeline, you're going to reference this application name.
Right. So in order, we're going to create the deployment pipelines because we have learned over time that employing continuous delivery has tremendous value. I mentioned that Asgard was kind of one of the forerunners of Spinnaker. There were a couple other applications at Netflix that had been built to create deployment pipelines. There was one called Mir that the engineering tools team wrote. Danny Zapata, who's on the edge engineering team, wrote another application that was also doing kind of continuous delivery to the cloud. And so as we started thinking about our next generation, we really wanted to build something that baked in there this concept of pipelines to deploy our assets. And so when I was preparing this talk, I wanted to recreate kind of a Netflix cloud. And this is where I think some of the challenges of building your own Netflix cloud, deployment cloud using Spinnaker come in, because you really need all this, right? Which doesn't sound like a lot, but it's non-trivial to get all this up and running for your application to get started. So at minimal, you'll need some type of source repository. In this case, I'm using GitHub. Spinnaker, at this current state, requires a CI server of some sort. And it makes sense because Spinnaker doesn't have its own CI server built in. So it's going to assume that at some point when you have a commit, you're going to need to build that code and turn it into your deb, right? So if we go back to our process, we're going to need to create a deb. This is going to happen on Jenkins. So in creating my own kind of mini Netflix OSS cloud, I had to stand up a Jenkins server. Spinnaker does have first-class understanding of Jenkins, and so if you configure it to say this is my Jenkins server, it will be able to say this is the job, and it will know exactly how to pull assets out of there.
Does it build the job? Does it create the jobs for you?
Jenkins jobs? No,
Yeah.
no. So in our Jenkins job, we will create a Jenkins job that will publish a deb to a Debian repo. This is something else you're going to need to have, some type of concept of a repository for your debs. At Netflix, we use Artifactory. I think that's a pretty good solution, only because I can now have my Java artifacts in there, and I can have my debs in there as well. And then once the Jenkins build is done, it will trigger a pipeline to run in Spinnaker, and one of the stages will say, do a bake. You'll have some type of bakery stood up in your environment that will pull the deb from there to do the bake, and then your pipelines will continue. One other security note, we will also recommend something like a BASTION to be installed in your cloud if you have a VPC. So all your SSH traffic can be routed through that BASTION. I'm not a security expert, I won't get into that, but so I see some heads nodding, so some awareness of this practice. So to get started with this, I think this is where, if people are looking to use Spinnaker and contribute back to Spinnaker, the getting started place is a great place to start. There are Kenzen Labs. They are heavily invested in using Spinnaker, and they have created Terraform scripts to create a Bastion, Jenkins, and Spinnaker instances. I did not use them because they fell short in some ways. So I still think the complete story of doing this with a one-button click for an organization is missing. So if anybody's interested in solving that problem, we take pull requests. And so we're going to start off with our Jenkins build. This Jenkins build is pretty simple. In previous years, we may have mentioned a tool we've used in the past at Netflix called the Job DSL. The Job DSL is a plugin for Jenkins that allows me in my code to define a Jenkins job configuration in GroovyScript, and then that is how I manage my Jenkins configuration. That has served us well in the past. But I think this is it would be a very simple job to just create GitHub and then run our Gradle command and have that published to a Debian repo. You probably won't be able to see it, this picture here. I've also exposed this as an artifact, my deb as an artifact in Jenkins. So in theory, you could also get away, I think, without having an artifactory or deb repository, but it's probably better to do that. I also think Jenkins or Travis CI integration will be planned in the future, so that might be an easier path to go as well. Yeah?
Regarding Jenkins, you have in the new Jenkins 2.0, you have a Jenkins file implementation for the pipeline.
That's right.
So that would be an easier way to create it.
Yeah, I haven't tried that out yet. But yeah, I think that you're right. I think having your build configuration inside your repo is definitely the best path. OK, thank you. So from there, now that we have our Jenkins job running and building, we can go back into our Spinnaker application and tell it to create a new pipeline. And so here in this pipeline, we're going to name this pipeline. And so you can have multiple pipelines for an application. This one we're calling a pipeline deploying our application to test. And then it's going to ask us to configure this pipeline. And this is this screen here is asking us what's the trigger. And in this case, I said it's going to listen to our Jenkins server, and it understands the concept of many masters. So one note at Netflix, as we've migrated Jenkins to the cloud, we have about 28 different masters in the cloud. So this will scale with you as you scale your Jenkins masters. Then it will allow you to select which job. And so in this case, we created a job. The name of this application happened to be Signal, and then that will trigger your application. From there, wow, this is really small, huh? Did I blow it up? Yes, I did. So this is the bake stage. So now we're going to configure a bake stage. And for this bake stage, we're going to give it a name, but it defaults to bake. You're going to tell it what regions to bake in, right? So one of the things we do at Netflix is when we bake, we don't bake in one region, then copy to all the other regions. If you want to deploy your application in multiple regions, we do separate bakes in each region, which you can think about. It's actually faster. We have worker nodes sitting in each region. One of the things that's not part of Spinnaker, or actually, sorry, we haven't open sourced this, but Spinnaker comes with this concept of what we call a bakery. And so a bakery is an API that sits in front of all the worker nodes, and you can make a single API call to this bakery, and then it will farm the work out to all the different worker nodes. There's a service in Spinnaker called Roscoe that effectively serves that function. So you can take advantage of Roscoe, and it will do that baking for you. There's some other features down here. You can choose what type of storage, and we have different versions of our AMI. So at some point, internally at Netflix, we're still using 2 versions of Ubuntu, and we're migrating away. So you can imagine a world where you have multiple versions of your OS available. And so those are some of the features for baking. And this is what a pipeline would look like inside Spinnaker. So here we have the bake phase. It successfully ran. And then we have it's a very simple phase where the deploy phase failed. And we have some details about the bake down here. You can click on the bakery details. This link would lead you. We have a separate system for our bakery at Netflix. In this case, this would just show you the logs of the bake. So it allows you to explore some of the pipeline features in that Spinnaker pipeline. So we've completed our deployment using Spinnaker, Aminator, and Nebula. One note I mentioned about the immutable server pattern is as we deploy new versions, essentially if I wanted to change code in my application as we've created this pipeline, a new code creates a new build, which creates a new deb, which I bake again, which creates a new AMI. And our deployment process is we would deploy a new ASG into the cloud. So now what we have is version 1 of our ASG with the old version of our code, which maybe has 5, 10 instances, and version 2 of our ASG that has, maybe a few instances. And then we can just route traffic back and forth. And oftentimes what we'll do is we'll keep the old instances around for a while, monitor how well the health of the new instances are doing. If something bad happens, we can just switch traffic back with one button click, and everything returns to normal, and we can destroy this old ASG and recreate. So it allows us this fast rollback feature by keeping these up and running. I'm sure you've noticed that there's an additional cost there, but that cost comes at increased reliability of our service.
You keep track of versions through these. You've got a concept of versioning in your source code management, your package manager, your EMI clusters, and your ESG groups.
Right. For applications, for applications, what only matters is that the version is unique and it's increasing, right? So what we typically do at Netflix is the version of the build in Jenkins will get put into the deb. So, and then that version gets put into the ASG group. So you will have some binding between those things. But so you can see how this is ASG 002 or ASG 001. Those are different instances, and those were actually, from AWS's perspective, those will be 2 different ASGs, right?
So the build job number, some proxy of it, is your global unique account.
Yes, yeah.
And Spinnaker keeps up with what AMI was, previous AMI.
Right, yeah, you can do it. I think there's a drop down you can choose manually, but I think it will just pick up the next increasing one. I think that's a configuration in the deployment. So
How do you deal, sorry,
go ahead.
how do you deal with developers and development teams that are trying out multiple flavors of something in parallel?
So they manage this all for them. So one thing I think I talked about last year a little bit, but the way that engineering tools works and most centralized teams work at Netflix is we build the tools and we provide all the features, and then we enable teams to manage their own deployments. So if this was a team at Netflix, they would be the ones defining what their deployment structure is, the deployment cadence, what their pipelines look like, how often they go to production. And we provide essentially what amounts to guardrails, right? So if you do things in the way that we recommend inside Spinnaker, you're going to get support from us, right? And if it doesn't deviate that much, we'll probably support you. But teams can have multiple ASGs running at the same time, multiple deployment patterns. We have a whole variety of different patterns that exist. So.
The scaling of the new instances that reminds me a bit of, Kubernetes or DCOS. Are there any plans to move on from pure AWS to perhaps something more sophisticated like those scheduler software?
For Kubernetes, no. And there's no plans to move off of AWS as well. We are experimenting with containers. And so there is a growing container service we have internally at Netflix. You may have heard something called Titus. And that is, and Danny has been doing more work on that side of the house, but I think that's Mesos based under the covers, is that right? Yeah. Yeah, and so we're building that up, and that in the deployment of Spinnaker at Netflix, you actually have two deployment targets, which is EC2 or Titus. And so you can deploy Titus Docker containers to Titus at Netflix.
That would speed up the AMI making quite considerably, right?
Yeah, yeah,
You also have that running in AWS?
yeah, yeah. Danny, you want to?
Spinnaker is actually multi-cloud, so it does support, even though we don't use it, we've got contributions from Microsoft, so it supports Microsoft Azure and Google's cloud compute. So we have other collaborators, so we get definitely the open source community more than building that in-house. We really focus on what we need to.
True. And in fact, I think the implementation internally of Titus is utilizing that other cloud provider API. Is that correct? Okay.
Just to clarify, so it's one instance of an application in a container, one instance of a container in a package, and you do all your resourcing by just the size of the actual machine instance. Is that right?
Yeah, so there is, yes. So I, as a team, might not know the best AWS instance size for my application. So our performance team will usually work with teams that don't know to help them size out, this is the best instance type. And then we generally have a lot of rules for scaling horizontally the size of your fleet. And that sometimes we even change based on the traffic patterns in the course of the day.
So you don't mix other applications on the same machine instance. Machine instance.
Right, right, yeah, yeah.
Question about test versus production. You take the same AMI and
Promote it.
test, and then you put it in production. Do you have to change rules for security or anything like that?
But that, I don't know specifically. I don't know if someone else can jump in on that. But the launch configurations may change per environment, and that won't change the AMI itself. Right. So if you go back to the AMI data will stay the same, but that launch configuration, which defines which security groups get applied, can change. But I don't think it changes in our environment.
So to deploy to production, is this like a test continuous delivery as well, or is it more just for production?
Yeah, I think you would find that there would be another promote. So what we have generally, pipelines would say, it would deploy to test. Then you would have a Spinnaker stage that would show, it would call down to Jenkins and say, run this test in Jenkins. And then if that Jenkins suite of job tests passed, then it would promote to the next step, which may be promote that AMI to production and then run a canary in production. So in this case, we would, you could run this instance, you could maybe scale up to two instances in production and say have a fleet of 50. You canary maybe 2 instances. You monitor that traffic based on our automated canary analysis suite. And then if that score is good, then you scale up that new fleet and you scale down the old fleet. So.
Do you find that developers still like to run the applications for testing purposes or whatever, like locally? And do they, if so, do they do that by baking an AMI first, or what's the flow there?
Yeah, they won't be baking an AMI locally for testing. This is something that actually Danny and I were talking about this earlier. There are still some challenges in getting, if you're not comfortable with testing locally, because in theory you can just stand up that Java service locally and do some testing there. If you want to get a more mature testing, you would probably go through the baking process. Containers actually change that story a little bit, because then now I can bake a container locally, bake a container locally, run it locally, route traffic maybe even to my local instance, and I can change my integration testing story. So I think that is where we're going to be exploring how we can improve that flow for engineers.
How often do you deploy? How often do you bake on this? Is it like for commits or?
Generally, what's that?
It's team by team.
Yeah. So each team can do whatever they want to, but if you want to deploy that commit, yeah, it'd be baking per commit.
And I mean, like usually it's like people deploy it or like they deploy it.
It varies. It varies from team to team. So there are teams at Netflix that deploy multiple times a day. To production, there are teams at Netflix that have a cadence, maybe once a week. And there are teams at Netflix that only deploy once a year because they're limited based on, say, they're deploying code onto Samsung TVs that have a fixed day when you have to deliver that code to make it into production line to produce that TV. So it really varies. And which is why I think the enablement model works, right? So we build tools that enable teams to go as fast as possible, but they choose the cadence that works for their team. And we are constantly trying to figure out what tools, where the leading team, the fastest team is going, as well. We need to serve them just as much as the team that only deploys maybe once a month.
QA processes and persons for testing. I take it you have to go through the package AMI, ASP, deploy to get them working on it. How long does that process take from the time that you kick off the build to run the deploy?
So I had a picture back here. I'm going to get lost now because it was way back. Right here. Oh boy. There it is. So you can see 15 seconds to commit for the commit to actually trigger a Jenkins build. The Jenkins build takes a minute. There's a lull here where Spinnaker kind of detects that the Jenkins build is done. And this baking process takes maybe 3 minutes, maybe 4 minutes, maybe something like that. So right around the halfway mark for this, we have an instance baked and ready to go. And then the instance launch in AWS takes about a minute or two. This is also additional boot up here, running some tests, and then we shut down the instance. So the whole process right here for this takes about 10 minutes, just shy of 10 minutes.
Team by team. So there'll be some teams that have a week-long test cycle. There'll be some teams that have
And so this varies too based on, like right here is the apt-get install process. So if we go back to my deb and I have a ton of requires, right? I require a lot of C libraries and maybe some other processes, this is going to take a long time. And then the bigger the delta, so the more stuff I install on the instance, the bigger the delta is between the base AMI and what I created, the longer that AWS snapshot is. So the bigger your application, the longer the bake time is going to be. So I don't know how much time I have. I think I'm running out. All right. I don't think I have anything cool to say. OK. That's it. So thank you very much.